Okay. Then we were discussing about how to create this mono property. And let's say a plain text equal input enter something. And then for character in plain text. So what you can get is you can get the, you can print the character value. Say ORD C. C is the character value. C is the character in this, and I'm getting the ORD. Let's write this. Let's say encryption enc.py. Let's run this. When you run this, you can see the character number. It is actually happening in the second layer, right? Encoding is this. Encoding means each character is represented using a number. That can be ASCII, EBCDIC, Unicode. Right? Those are the methods used in character representation. So that is representation, and also that is called, let's say, hello, how are you? This is my message. And it's printing the relevant number or the Unicode or ASCII code related. This is ASCII code, actually ASCII code related to the particular character. Well, let's print this and end with space. Just printing in the same line. Okay, you can see now, hello, how are you? And it's printed with the character number. And when I see the number, what I can do is I can add 1 to this number. So if I want to change this by 1 position, add 1 to this number. Then when I save this and run this, you can see it's hello. I'm giving the same message to compare how are you. It's adding, no. Sorry, I have done wrong thing. Let's add to the converted one. Now run this. Okay, I'm writing hello. How are you? And print it. Now it has added 1. This was 104. Now it's 105. It was 102. That 100. Okay, after adding, now 108 is 109. 11 is 12. 32 is 33. Likewise, it has added. Okay, after adding that, I'm again converting this back to CHR character. After adding 1, I'm converting back to the character. Now you can see the second character. Okay, let's run this, and this is the message. Hello, how are you? I'm typing the same message. Hello, how are you? And print in the added message. HE. Okay, this is with space. But if I remove the space, right, let's remove the space, and this is more clear now. And run this. Now you can see hello, how are you? And this is my plain text. It's converted to ciphertext. This is my ciphertext. Right. If you want to add 2 characters, that is also possible. 2 characters. Then you can see hello, how are you? And this is the one. This is the message. This is encrypted message. And how to decrypt this? Well, let's say this is the function for encrypting. Def encryption. This is encryption function. Let's write a decryption function. That is the reverse of this. So decryption function, you can write decryption dec. So now you have to get the ciphertext. Enter ciphertext. Okay, for C in range ciphertext, same characters. Then let's get the character, subtract 2, and end with the blank. Okay, now let's see the encryption and decryption. Right, if you didn't understand, please ask, I'll explain again. So adding 2 will give the encrypted, and removing 2 will give the decrypted one. Let's try this. encryption, ENC, bracket, ask and enter something, hello, how are you? And you can see the encrypted message. This is the encrypted message. I want to decrypt. Ask in the ciphertext. I'm going to copy this and paste it here. And after that, there are some quotations. Yeah. Let's escape that. Seems not escaping, right? Okay, let's give as this. But you are anyway, you are getting that. Hello, how are you? You're getting the message. Hello, how are you? After encryption, this. Hello, how are you? So this is decryption. After decrypting, you will get hello, how are you? Message back. Understood how encryption decryption happens? This is not. This will not be asked in the examination for sure. But if you want, like for your knowledge, you can try this, right? Just take a screenshot. That is just for your knowledge. Because you can simply do this. One alphabetic character change, you can simply do this. Okay.
Okay, sir.
Right. Did you understand the concept?
Yes, sir.
Difficult. If difficult, please ask again, right? I can explain again. It doesn't matter. Because you have to get these things correctly to the head. That's why I'm showing this in practically. Right? Encryption, decryption. But this monoalphabetic substitution or this encryption mechanism is like too childish because anyone can guess. When there are, especially when there are quotations, you can get that is the space. That might be something like space because it looks similar, right? It looks similar. So that is not very good method of encrypting the message. But you have some other methods. Okay? So some other methods. Another thing is like, okay, let's say this is the message. Let's encrypt this. I just want to encrypt that message and I'm running this. Encryption. Ask this message. Okay. So this is the decryption. I want to decrypt. Now it's asking the message back. And I'm putting the message and I'll get this. Right? So that is possible to encrypt and decrypt. But the thing is, it's easy. Algorithm is easy. Right? Let's write this. This is the algorithm, but that is easy. Right? Therefore, there are other methods, some other methods like you can use disposition based. And disposition based algorithm for encryption. Right? This is the encryption part. And disposition based algorithm, I have to write like this. I pass a space. I space. I space want. Let's use capital only. I want, again space, T2 space MIEET space need you space TODAY today space 9 30 p.m. space THROUGH true space Google GOOGLE space meet MEET. Okay, now so I have written like this. I want to meet space YOU meet you today. So this message is there, but what I'm going to do is I'm going to write this in this way. Now what will happen? Is it easy to guess or difficult to guess? Disposition based. Is it easy to guess or difficult to guess? Hello? From you. Is it easy or difficult? Now?
Difficult.
Yes, difficult. Because that is disposition, right? We don't know how that has happened. So what happened after disposition if you substitute again? Disposition color substitute. Now it is even more difficult. And there's another way. So you can disposition, substitute and use a key. There is even more difficult, right? Right? So likewise, you can use many methods to decrypt. So this is disposition based. And you can also use a key. There's another way of encryption, key based. Here you are using a key. You have the message and you are using a key. Key is this, like let's say key is sit me. Right now, sit me will wonder what is happening. So I'm going to copy and paste the same sit me here, up to here. Now what you're going to do, you're going to add this character with this character and produce a new character. I plus S, so value of I plus value of S will be added. Right now, actually that is also substitution, but different substitution. Make it S add venno, space eකට I add වෙන්නේ. W එකට T add වෙන්නේ. A එකට H add වෙන්නේ. Right? ඊළඟට T likewise different character is added now. So therefore, you cannot guess that without the key. Understood the key-based algorithm? Did you understand the key-based algorithm or not?
Yes, sir.
Right. You are adding this character value with this character value and creating the new character. Let's add and create a new character. Then it's very, very, very difficult to get that character back. Right? Then it's very difficult to get that character back. That is the that is what happening in this decryption. Actually, so what you do actually, you are converting this to binary. Right? Let me show what's happening. It's if you get a character, let's say the value of character, let's say X, that is ORD of character A, letter A. Right? So that is X is 65. You convert that to binary X, and this is the number now. You're just converting this to binary. X is taken, converting this to binary, and you will take the other character, let's say S, and let's convert S to binary, bin S, bin ORD, the character S is also converted to binary. After that, UXO XO is this one, right? As I remember, UXO, this one, just print, this is a lengthier operation. XO, this one with, this one is XORed with this one. Okay, then, oh, what has happened? Okay, just having this number 0B, you XOR that with this binary. Yeah, you're getting a new number. After XORing, you're getting the new number. So what has happened here? Bin, make it INT also, right? Int. So that is now even more lengthier. Int. එක character එකෙන් character එකට මේ වගේ XOR කරනවා. So that is what happening in this. What's going on? ORDS taking the bin. Let's remove this one. Two binaries. Unsupported operand for S. But when you're doing this, okay, so let's take this one, an integer of this one. No. So asking the base 10. I had to remove the brackets, right? So that's the thing. I have to remove the braces and give the number, take the number. Okay, anyway. So what is happening here is taking this binary value and taking this binary value. When you XOR both binary values, you will get another value. But if you want to get that again, so let's say bin binary of 50. If you XOR that with the key, so this is complex operation, but still it's valid. If you XOR this with 50, sorry, again you have to get the bin 50. So this is not supported because of return in string. And if you XOR this with 50, make a 50 XOR karo, what apo ganna puluwan ar original. So that is how decryption happens. Right? Let's say bin 65. It's bin 65. That is this character, right? That is same. Okay, so I think so let me short this, like let me explain this again how I have done this. එක character එකක් ගමුකෝ. මම උදාහරණයක් විදිහට ගන්නවා. Let's take one character. How this addition happens, right? Let's take one character. I want to encrypt character X. එතකොට මම ගන්න character X වල binary ආගේ. X වල binary ආගේ. So this is the sorry. ORD X වල character ආගේ ඉස්සලා. ORD X. So let me clear everything. Let's run this. Carefully look at this now, right? I just want to show you the actual picture. This won't be asked in the examination, but this is what happening. මේක කියලා දෙන්නේ theory එකේතොට පාඩම් කරන්න ඕනේ. මේ තියෙන x කියන character එකේ මේ character එකෙන් character එකනේ. අපි හිතමු i ගමුකෝ. හරි. i. මේකේ විදියටම i එක්ක s එකතු වෙන්න ඕන. ඒක කරන්නේ මෙහෙමයි. You take the value of I and binary of the particular value. 73 නේ. 73 binary එක. This is the binary. Then s. Value of s, simple s. Value of s is 115. Value of s is 115. ඒකේ binary එක. ඒකේ binary එක. 115 වල binary. This is the binary. Okay, what is happening here when encrypting this key and key එකේ තියෙන character එකයි value එකේ. So this is the key character, this is the message character. Message character and key character is sent to the XOR gate. යාව XOR gate එකකින් යවනවා. That means this binary, මේ binary එකයි ඒක XOR කරනවා. මේ තියෙන XOR symbol එක. මෙන්න මේ binary එකත් එක්ක. It's sent to the XOR gate. එතකොට අලුත් character එකක්, අලුත් symbol එකක් හැදෙනවා. ඒ තමයි 58 58ත් අපි binary එක බලමු. Binary 58 කියන්නේ මේක XOR කරාම හැදෙන්නේ මේක. ඕනනම් බලන්න කරලා. 1 1 XOR කරාම බිඳුවයි. 1 and 1 XOR 0. 0 and 1 XOR 1. හරිනේ. 0 and 0 XOR 0. Then 1 and 0 XOR 1. Here 1, here 0 XOR 1. Here 1, here 0 XOR 1. Here 1 and here also. Is it 1? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1 and 1 XOR 0. A 0 එක මෙතන indicate කරලා නැහැ. Because here 1, 2, 3, 4, 5, 6. මෙතන බිඳුවක් එන්නේ නැහැ. That is not indicated here. So you are getting this number. Right? Okay. This is the encrypted message. This is the encrypted message. මේක යනවා අනිත් end එකට. ඒ කියන්නේ මේකේ character එකේ binary එකයි මේ character එකේ binary එකයි both will be encrypted, and this is the encrypted number that will be sent to the other end. So other end people will get that. Okay. ඒගොල්ලන්ට key එක ඕන. Key එක කියන්නේ මේ සිත්මිගේ S අකුරනේ key එක. ආයි key එක තියෙනවා නම් decrypt කරන්න පුළුවන්. ඔන්න මම පෙන්නනවා. සිත්මිගේ S අකුරේ code එක මොකද්ද binary එක? S binary value is this, right? Agree? S වල binary value එක 115 නේ. දැන් S වල code එක 115. ඒකේ binary value එක මේක. Are you agree with that? Code of S is 115. Binary of 115 is this. Agree or not agree? Hello?
Agree.
Nice. Right, okay. So this is the binary value, right? Okay. I'll take then may decryption end again. Decryption end, they will take the binary value of this and XOR this back with the key. Decryption party will also have the key. So they are using their key too. This is the key. So key S. Key S. S message. This is the message that they go. They will encrypt that. They will export that. And that will give you 73. What is 73? 73 is character I. Understood how decryption happen in the other hand? When you encrypt 73 with, when you add XOR 73 with 115, you will get 58. When you XOR 58 with 58 again with 115, you will get 73 back. So that is the decryption process. You can manually also do that. 73, try to get the binary, convert it to binary, get 115, convert it to binary, XOR both, and it will give 58. When you XOR 58 again with 115, you will get that 73 back. So that is the magic of binaries. That's why they like key-based algorithms. So key-based algorithms are more popular because it is easy to XOR, easy to implement, easy to encrypt. No need to do hard maths. Understood or not? If not, let me know. I'll explain again. තේරුණේ නැත්තම් කියන්න ආයි මම explain කරන්න. මම ඔයගොල්ලන්ට exercise එකක් දීලා explain කරන්නම් ඊටත් වැඩිය හොඳයි. එහෙනම් තේරුණා නේද එහෙම? Did you understand how encryption happens and how decryption happens? No.
Yes, sir.
Okay. How many of you have not understood? Can you raise your hand if you have understood? If you understood, please raise your hand. Okay. Shimla. Only Shimla. Sit me. Two. Right. Others? I think you didn't understand. Okay. Four. Others, I think, right, there are some issues, right? Okay, let's do simple thing. Let's do simple mathematics to understand this. Right, forget about the characters. Let's say character A is 10. Let's say character, the encryption, we want to use encryption, and character S is also used. S is, let's say 15. Let's have some values. What is the binary of 10? Binary of 10 is 1010. Just convert it to the binary. They can convert karana. Then mataka naha kiyanne epa. Palaweni paadam waladi karawo. 15 into binary 1111. Can you XOR both and tell me the value? 10 plus 15. XOR and tell me the value. Quickly. XOR 10 and 15. Tell me the value. XOR this one with this one. XOR gate mataka if number of ones are odd, then it is 1. If number of ones are even, then it is 0. Okay, XOR and tell me the value now.
0101.
0101. 0 1 x unama ones gana ekai odd. 1 x unama ones gana dekai even. 0 1 x unama ones gana ekai odd. 1 1. Okay, this is the, so this is encrypted message, and this is the key, and this is the plain text. Okay, let's say this 0101, which is equal to 5, is another character. Let's say that character is H. Now the other party is getting this character H. Now the other party is getting the character H. What they are doing, they also have this key, that is character S. They XOR back with the key. Message key then what will happen? Let's say the character H is 0101, and they will XOR that back. They will XOR that back with 1111. So what do you get? What is the message that you are getting? 1 and 1 1 XOR karam 0. Then 0 1 is 1. 1 1 0. 0 1 is 1. You are getting back, that is 10. 10 is your message A. So this is how encryption and decryption happens in key-based algorithms. Right? Okay, there are 3 kinds of algorithms. Right? This is simple explanation. Right? This is simple explanation. Let's assume A is represented using 10, S using 15, and H using 5. Based on that assumption, you can encrypt and decrypt. Oh, sorry. Based on that assumption, you can encrypt and decrypt the messages in this way. Okay, I would like if you can write down this is very important topic, even though we are going to discuss network layers. Encryption is very important. It's coming under security, also coming under networks. So please write down encryption and decryption. Write down encryption, then write down decryption. And there are a few methods of doing that. So one is like monoalphabetic substitution. That is method 1. There's another method. That is disposition. You change the position of the letters. And there's another method. That is key-based algorithm. Please write all 3 and explain this. Okay, there are some files, so which take more than required space. So for an example, let's say image file. Let's take image file, like for an example, let's say 8-bit image, 8-bit RGB image, 8-bit depth RGB image. So if image size is like image size, let's say image size is calculated based on the bit depth. So let's say width is 2000 and height is 1000 of this image. The number of pixels equal to 2000 pixels into 1000 pixels. This is pixels, right? Px. This is also px. If you have width 2000 pixels, height 1000 pixels, total number of pixels is this. So that is 2 into 2000 and 000, 2 million pixels. We call 2 megapixels. 2 into 1000, yes, 2 million pixels, 2 megapixels. And then, so what is the size of 1 bit? So 1 pixel. Actually, 1 pixel has 3 colors with 8-bit depth. එක color එකක් 8-bit. Then total bits for 1 pixel. Therefore, total bit for 1 pixel is similar to 3 multiplied by 8 bits equal. So this is actually 3 bytes. Then what is the size of image? Size of image. මොකද එක color එකකට bit 8ක් තියෙනවා. color තුනට bit තියෙනවා 8යි 16යි 24ක්. ඒක 8ෙන් බෙදුවම 24 8ෙන් බෙදුවම you will get 3 bytes. Size of image is